Hidden in the heart of the African continent, the old Katanga, a barren and almost desert region, remained unexplored and unknown until the end of the last century. For a long time, though, the native tribes had mined and smelted copper. Their methods were born of experience and were curiously effective. At the dawn of the century, European pioneers discovered the untold wealth of this apparently unclaimed soil. In a few years, a mighty industry was to rise, which would draw thousands of Africans and Belgians alike to the Katanga. Copper is found in the Katanga soil in the form of sulfide or oxide. The metallurgical treatment of these two ores greatly differs. We shall examine each one in turn. The underground Prince Leopold mine at Kipushi produces more than 1 million tons of sulfide ore per year, which contain 100,000 tons of copper and 80,000 tons of zinc. The mine extends to a depth of 1,700 feet. To combat dust, the jackhammers are fitted with a water spraying system. The shot firer puts the charge in the blast hole, connects the fuse, and rolls it to ensure sufficient burning time. As soon as the fuse is lit, the occupants immediately leave the area. The contents of the trucks are tipped into a skip, which hoists 5 tons at a time to the surface. The ore is directed to the concentrator nearby. The crushers have an enormous appetite. The two of them can swallow some 90,000 tons of ore per month. A conveyor belt takes the ores to the granulators. From the granulators, still by conveyor belt, we arrive at the wet grinding section. There the granules will be crushed into a fine powder. The grinding is done underwater in ball mills. Reduced to 1/10 of a millimeter, the ore particles are taken to the flotation section. Chemical reagents are added. Air injection causes a froth to form, which gathers up particles rich in metals, while the barren ones sink to the bottom and are evacuated. This process is that of selective flotation. The froth goes to the settling tanks, where it thickens. The concentrates thus obtained are pumped to the filtering plant. Finally, we obtain cakes, which contain 29% copper and 58 to 60% zinc, according to the nature of the concentrate. "492 feet high, the chimney stack of the Lubumbashi smelting plant, which has the double result of agglomerating them and eliminating most of the sulfur. The sintered ores are tipped into dump cars and cooled. Other dump cars convey the coke. An inclined plane brings them to the mouth of one of the 4 water jacket furnaces, so called because their walls consist of metallic water-cooled jackets. At a temperature of 1300 degrees centigrade, the impurities will combine to form a fluid slag which floats on the surface. Underneath the slag is found the metallic part, the matte, a mixture of metallic sulfides with a high copper content. Air necessary for fusion is injected through air nozzles called tuyères. From time to time, they have to be unclogged with a steel rod. The copper matte runs through a channel to a furnace, which will keep it at the right temperature while awaiting conversion. As for the slag, this is granulated by cold water before being dumped on the slag heap. The holding furnace is opened by means of a blowtorch. The matte is cast into steel ladles of 4 cubic meters capacity, or 15 to 20 tons. It is then transported by a loading bridge at the same height as the converter. An enormous cylinder about 30 feet long and 15 feet in diameter. The conversion process lasts from 3 to 4 hours. This operation converts the metallic sulfides into copper by a final elimination of sulfur and other impurities, mainly iron. Compressed air is blown into the liquid matte through 50 tuyères and transforms the sulfur into sulfurous anhydride, which is exhausted through a tall chimney stack. The matte has now become crude copper called blister. The copper is taken to the casting furnace, thus freeing the converter for the next operation. The molten metal is cast into ingot molds. The ingots weigh from 300 to 400 pounds. They contain almost 99% of pure copper. The Lubumbashi plant produces over 100,000 tons of blister copper each year. Ores of a different kind are extracted from the open-pit mines surrounding the town of Kolwezi. These are oxide ores with a copper in association with cobalt. 13 million cubic yards are removed each year by powerful machines worked by skilled men. Dump trucks and trains take away their cumbersome and worthless loads. They are working day and night. The barren earth having been evacuated, the ore body is exposed. This will be dislodged by explosives. Churn drills make the blast holes. Then the charges are installed. The last explosion has hardly died away when the merry-go-round of dump trucks starts up again. Each truckload represents some 20 tons of ore. Crushing. Grinding. Addition of reagents. Flotation. Decanting and filtering until a concentrate is obtained with a content of about 28% copper and 6 to 8% cobalt. The stock is regularly drawn upon. Always is only one stage. The concentrates are now sent 92 miles east to Jetterville, the most highly developed industrial town in the Katanga, and fed to the conveyor belts. The operation we are going to see now is called leeching, a technical way of saying washing, but a special kind of washing since it's done with sulfuric acid. This washes the particles by dissolving the metals they contain. The pulp obtained is treated in classifiers and thickeners built on the hillside. the copper-bearing solution overflows and is evacuated. The filters separate most of the remaining solid particles. The clarified solution contains from 55 to 60 grams of copper per liter. It passes to the tank house, where the copper is recovered by an electrochemical process. To effect this electrolysis, thin copper sheets are used called starting sheets. Immersed in large tanks, the starting sheets are connected to the negative pole and thus act as negative electrodes or cathodes. The direct current needed for this operation is produced by generator groups which are fed by a current of 6,600 volts. By the action of the electric current, the starting sheets become covered with copper, each sheet gaining about 110 pounds of copper in 5 days. When they have gathered their share of copper, the cathodes are removed from the solution. Here they are rinsed. Then taken to the reverberatory furnaces. For even though of great purity, the cathode copper must still be fire refined before it is ready for industrial use. Each furnace has its casting wheel. Bone ash placed in the bottom of the molds helps to dislodge the solidified ingots. The copper obtained is practically pure, since its metal content is over 99.95%. Water is played on the ingots to hasten the cooling process. The copper wire bars are carefully inspected. Any defects are noted. These defects are removed by a pneumatic chisel. This is an important operation, for the ingots go from here to the rolling and wire drawing mills in many countries for direct manufacture. While awaiting shipment, they are piled in the stockyard. The incantations of the primitive smelters now seem far away. Their memory is already beginning to fade from our minds. 240,000 metric tons of copper are produced each year in these plants, and gold. 4 dams with hydroelectric power stations are able to furnish 2,500 million kilowatt hours per year. In the rapidly expanding modern cities, 20,000 Europeans and 250,000 Congolese are uniting their efforts to build a happy and prosperous society. The Katanga now pulses to the rhythm of the great industrial centers of the modern world.